So I'm gonna go ahead and share my entire screen so I can give a quick demo. Cool. So with the new version of Daft, you can actually run Daft with Ray and with a new flag that we've added, which is this Daft, sorry, let me clear this. Daft enable. So if you pass in Daft enable ray tracing equals 1 into your environment variables, and make sure that this environment variable is set all across your system, right, on your local machine and also on the Ray cluster. And then if you run Daft on the Ray runner, we will start producing JSON traces. And what these JSON traces enable you to do is that you can now look at what Daft is actually doing under the hood in its interactions with Ray, right? So I have an example here already where I ran a workload and was able to produce that trace. The way that I ran this workload was, using our Daft Connect tool, which is an easy way for you to spin up a Ray cluster on an AWS account. And so what this workload looks like is, let me show you. So this workload is very simple. It's a deduplication workload. It's reading from this S3 bucket, our RIP pajama parquet. It's about, I believe in this case, 100 gigabytes to 1 terabytes worth of data. And then we're running this very simple deduplication process, which will take that data and deduplicate it by a column, which is the raw content column, right? We're just trying to make sure that our data doesn't have any, close matches in terms of duplication. The workload itself is pretty interesting. It has a group by and aggregation. And then later on, it has a dot distinct operation, right? So you'll see that there are some shuffles in the workload that need to be done. And it's going to be very interesting for us to dig into how Daft is achieving this on Ray. Other things to note is that, all we're doing here is we're reading from Parquet, running this deduplication workload, running all these data frame operations, and then lastly calling a dot collect, which is a very simple, just end-to-end example of like running Daft and then collecting all the data and persisting that in memory. And then now we can take a look at what that looks like in Ray. So let me hop over to the Ray dashboard. So this was the completed run that I had previously. It ran in about 6 minutes, which is why I didn't want to run it on the demo itself. But I can show you what running it looks like. So if I go back here, let's go ahead and activate my environment. And then if I just do a Daft submit, right? This is the CLI tool provided by Daft Launcher. We can submit a job. And so I'm just submitting the entire dedupe.py script as a job that I want to run on my cluster. And submitting this will now spin off a new job. And so if I go back to my dashboard, you'll see that there's a new pending job in my Ray cluster and it's running. Since I actually specified the environment variables to start producing these traces as the job is running, if I go into these jobs, you'll be able to see that it will start producing traces, right? So if you go to other logs, see, hopefully this works. Yeah, so if you go into the, sorry, let me do that a bit slower so people can follow along, right? If you go to your job, click into your job, and now if you go to this logs and hit other logs, you'll see that it currently filters on the job ID, but we don't want that, just delete that. And you'll see a whole bunch of other jobs. Look for the Daft folder right here. And these are the traces that Daft is producing, right? So one of them is actually in progress right now, the more recent one, this 2013 one. This was a historical run that was already ran. And so let's take a look at the one that was already ran, right? And so the way that you can visualize this is you can go to this website, ui.perfetto.dev. It's actually a Google provided website that you can use to view these traces. And then let's take a look at a trace. So let me find my downloads. Where do I find my downloads? Try this, doing this. I believe this is the right trace. You shall see. Okay, so yes, so this is the example trace from that job that we just ran. How do we look at this trace, right? So first off, you'll see that the Daft scheduler, this is what the scheduler is doing. We actually schedule things in waves of tasks that we fan out to Ray. And and you'll see that it's like wave one, wave two, all the way, like many different waves of tasks that we're fanning out to Ray. And you can also see that these tasks are being run on Ray, right? If I scroll down on this execution, you'll see a whole bunch of tasks happening here, where we can see the different stages of sending a task out to Ray, where this is the entire life cycle of this specific task. This is when we started a dispatch in our scheduler and when the task actually executes in Ray, in this like dark green patch. And so this gives you a really good view of, from Daft's end, what it looks like as we're sending stuff out to Ray, right? So this is interesting, but actually one of the most useful views here is this view down here, which tells you the stages coupled with, sorry, one second. Yeah, these stages coupled with the nodes that are on your Ray cluster, right? So let me give you an example. So in the query that I just showed you, there's actually 3 stages of queries. Stage 1, well, I guess it's in reverse order. So stage 3, in this case, this one, has all of these different tasks within that stage. And this stage is actually, if you click into these tasks, you'll see that it's actually, if we click into the task up here, you'll see it. You'll see that these stage 3 tasks are actually a scan into a project, into a map partition, aggregate, and then fan out hash, right? So this is exactly what Daft is running within each task. And then you can also see where these tasks are being run because these two are the node views, right? So I have 2 nodes running in my cluster. And for this stage, these are all the tasks associated with this stage. We'll see that it's fairly well distributed within a given node, right? These tasks are run one right after another. And so they're very well packed, which is great. That's exactly what we want to see. And also they're very well distributed across these nodes, right? Like you'll see that both nodes are extremely busy throughout this entire execution. But you'll also notice that like these tasks are fairly heavy. They are 29 seconds each. And so every time you run this pipeline of like scanning into map partitions, into whatever, into like fan out hash, this entire pipeline runs in about 25 seconds. And there should be a way also, if you select all of these, you should be able to see, here's the total amount of values, and then you can also do operations like checking out what the average runtime of a given task is. So this gives you a very good idea of like bottlenecks in your query, right? You can look at this and say, okay, my query clearly here is bottlenecked by the scan, reading data from S3, right? Because all of these belong to stage 3, which is the scan operation. That's just reading data and then doing a bunch of operations. In subsequent stages, we'll see that they actually complete in very quick order, right? So stage 2, the next stage, which is actually the group by, these operations are super quick, right? Just from here to here. So this time is about 15 seconds. So the group by operation is actually really quick in this query. And then the last stage is also super quick, which is, I believe, after you've done a group by, we're just going to collect it in memory. And so it's super fast. So yeah, this view gives you a very good view. This trace, sorry, gives you a very good view of what Daft is doing under the hood when it runs your query. And if you ever find yourself needing to debug a query or like see why a query is running slowly or how Daft is interacting with Ray, you can kind of use this view to do that. Yeah, I'm gonna pause there and see if Chan or if anyone on the call has any questions about how to use this tracing view.
No, it looks very cool. So what are like some of the things that you would be able to catch with this tool, like besides just like
Yeah.
seeing how the tasks are run and stuff like that?
Yes. So one thing, for example, that's been useful for me is I want to see whether Daft is making the right requests to Ray, right? So when Daft makes a request to Ray, we actually ask Ray, hey, Ray, please give me 100 gigabytes in order to run a given task. And that's actually possible now. If you click into one of these tasks, you'll see that here, this is the resources that Ray assigned to the task, right? So you'll see in this case, it's 1, 2, 3, 1, 2, 3. Ray is assigning about 158 megabytes worth of memory to a task, right? And so some additional things we can add is we can also start adding more information about how much memory did the task actually use. And so that will give us an idea of, we asked Ray for 158 megabytes, how much did we actually use in practice, right? And so as a user of Daft, you'll be able to debug or like send us any issues where you're like, hey, like Daft thought that this thing was going to take 158 megabytes, but it actually took 1 gigabyte, right? And that's where problems in the system will start to appear. But this view gives you very good functionality around debugging all that. So you'll see that different tasks had different estimations, and under the hood, there's a lot of logic that goes on to determine this number of how much memory to request from Ray. Other really interesting things that you can also see from this trace is, for example, sometimes if you're wondering, hey, is this like Daft's fault or is this like Ray's fault? Like, why is this thing running slowly, right? And you can actually suss that out here, because in this view, this talks about how when Daft sends something out to Ray, that's what we call a dispatch. How long does Ray actually wait before actually running the task? And so you'll see that in a lot of these cases, Daft actually sends out the dispatch fairly early on down here, right? But it took Ray a whole, like from here to here, that's, a whole 1 minute and 54 seconds before it actually runs the task, right? Before this green bar actually runs, it takes a whole 1 minute and 54 seconds. So this tells you, for example, that in fact, we are sending these tasks out to run on Ray, but Ray perhaps doesn't have the resources to run it. And so it just waits for a really long time before actually executing this task, which is this dark green box. And so, Daft is doing a pretty good job at dispatching these things, but it's just unfortunately Ray doesn't have the resources. And so as a user, you might consider, for example, in this case, increasing the number of machines, right, in order to run these things. And after you increase the number of machines, you should be able to come back to this graph and notice that, okay, now I have one, in this case, I have two nodes, but if I increase the number of machines, you have way more nodes, but you also see that each node will be responsible for way fewer of these green tasks, right? So you'll see the total runtime of the stage go down dramatically. So that's all really cool stuff that you can do once you have this view of looking at what Ray is doing, what Dapt is doing, and debugging from there. Yeah, so that was kind of it for today on the deep dive angle. So this is definitely a work in progress. So today, at least the way that we intend for this to be used as a post-run analysis, right? So after you run something, then you get some results that you can use to like analyze your run. I know that a lot of people have been asking about, hey, as I'm running the query, can I get some live feedback? Like, how is my Daft query doing? And so that's something that we're actively working on and exploring as well. But a lot of this gives us the fundamentals that we need to build those kinds of systems where, we have some live feedback from the query as it's running to inform our users how the queries are executing. But yeah, would love to show more on that front once we have more updates there. But yeah, that's it for the demo today. Cool. That's it on my end. Chan, was there any other things you wanted to cover today before we finished up?
No, I think that was all. Thank you guys for joining us for the last contributor sync of 2024. So sad. But we will be having a lot of very exciting updates in the new year. So look out for that. Our next contributor sync will be, I believe it should be January 30th, which is the last Thursday of the month, which is how we typically do. But yeah, stay in touch in our Slack community, and we'll always be sharing updates there. I think that's a wrap.
Cool. All right.
Awesome. Thank you guys. See you next time.